Here, we will split up 1 over v plus 1 times v plus 2 using partial fractions. We can write 1 over v plus 1 times v plus 2 as a fraction a over v plus 1 plus b over v plus 2. In this process, we'll figure out what constants a and b should be in order for these two expressions to be equal. To do this, we'll clear the denominators by multiplying by v plus 1 times v plus 2 on both sides. On the left-hand side, we'll simply be left with 1, while on the right-hand side, we'll multiply each term by v plus 1 times v plus 2. This gives a times v plus 1 times v plus 2 over v plus 1, plus b times v plus 1 times v plus 2 over v plus 2. In here we get simplifications as well. In the first fraction, v plus 1 over v plus 1 is just 1, while in the second fraction, v plus 2 over v plus 2 is just 1. So we're left with a times v plus 2 plus b times v plus 1. And remember, this is equal to our left-hand side, which is 1, leaving us with the equation 1 equals a times v plus 2 plus b times v plus 1. From here, there are a few ways that we can find a and b. We'll proceed by distributing a and b across v plus 1 and v plus 2 to get 1 equals a times v plus 2 times a plus b times v plus b. And now we will separate like terms. AV plus BV can be written as a plus b times v plus our constant 2a plus b. Now we need 1 equal to a plus b times v plus 2a plus b to be equal as functions, in other words for all values of v. So we can find a and b by lining up coefficients on both sides. That is, our coefficient of v on the left, which is 0, should be equal to our coefficient of v on the right, which is a plus b, and our constant coefficient on the left, which is 1, should be equal to our constant coefficient on the right, which is 2a plus b. So doing this, we get that a plus b is 0, and 2a plus b equals 1. From the first equation, we get that b is negative a, and when we input that into our second equation, we get 2a minus a equals 1, which leaves us with a equals 1. So by solving this linear system of equations, we found that a equals 1, and thus b, which is negative a, equals negative 1. So we can conclude that 1 over v plus 1 times v plus 2 is equal to 1 over v plus 1 minus 1 over v plus 2.